In this video, we're going to be looking at linear inequalities and how we use those in the exam. One of the most common things we have to do is to put inequalities onto a number line. So let's say this number line is x, and we want to show x is less than 3. Okay, so first thing you need to do is to learn the less than, greater than, less than or equal to, and greater than or equal to. Okay, put those on a flashcard if you're not sure, but we can use some little hacks to help us in the exam. With the less than, we're going to put a circle representing our inequality, and that arrowhead is kind of pointing in that direction. If you imagine an arrow like this, that is how we do less than. And if it was greater than, imagine an arrow going in that direction, we would go kind of like that. So we can use this sort of arrowhead idea to help us if we're not too sure. So there's 3, x is less than 3 is shown with this arrow, and essentially all we're saying is, can you think of a number that is smaller than 3, like 2 or 1? Or we could have 1.5, it doesn't have to be whole numbers, but in the exam they often use this idea, the idea of the integer or whole number. Okay, so this is less than, this is greater than. How do we do less than or equal to? We have to fill this circle in, make it a closed circle. Hard to do on the computer, but when you're in the exam, kind of fill that in properly. And that will be your less than or equal to, and greater than or equal to will just be pointing in that direction. Okay, so the next level up of that is the double inequality, something like this. Okay, let's try to represent that on a number line. So this is a double one. So we're going to have a 3 and an 8 at our extremes. 3 and 8. And x is kind of sitting in between the 3 and the 8. And that's how you kind of want to imagine this. X is between 3 and 8. So when we do our circles on 3 and 8, x is in between them. So we kind of connect them and do the arrows pointing inwards. So x is somewhere in here. Okay, that's where x is going to sit. Okay, we have to be aware of the less than or equals to on this one only. Okay, it doesn't have it on the 3. And then they might ask you to list the numbers that satisfy this inequality. And that just means give me some numbers where this would be true. So think of a number between 3 and 8. Let's try to do it in order so we don't miss any. 3, 4, 5, 6, 7, and 8. And then we have to be a little bit careful about the extremes, because when you look at this half of the inequality, it's saying x is less than or equal to 8. So 8, it's fine to include 8 because of the equal sign. But on the bottom end, if I read it like this, x is greater than 3. X has to be more than 3. So 3 is not allowed to be included. So these are our integer whole number values that can satisfy this inequality. All right. Last thing we have to do is we actually have to solve inequalities. Something like 2x plus 1 is less than or equal to 11. Okay, and as soon as we see these, a lot of students freak out. Just pretend that this is an equals sign. If that was an equals instead, it doesn't matter what the inequality sign is. If that was an equals, what would you do? You would take away 1 from both sides, like this. 10. Okay, so the plus 1 and the minus 1 disappear, and we subtract 1 from this side, and then I would divide by 2. So I would divide by 2 here, and I'd get x and 5. And that's it. Just pretend that the inequality sign, whatever it is, if it doesn't matter if it's that way round or whatever, pretend it's an equals and do your normal thing. We do have to be careful sometimes if you've got negative numbers. If you divide by a negative, you have to be careful, but most students would not do their equations and create a negative. Okay, so what I mean by that is if I had 4x plus 1 less than or equal to 2x plus 5, okay, most students would subtract 2x from both sides, and then you'd have 2x plus 1 and 5 on this side. Okay. If you were a bit crazy, you might subtract 4x from both sides, and you would have 1 less than or equal to negative 2x plus 5. Like, I don't know any student that would do this. But if you did, and you carried on, and you subtracted 5 from both sides, and then you wanted to divide by minus 2, then we have to be very careful about dividing by a negative, because that will switch the sign around. Okay, this virtually never happens when students are solving these, because they will never try to create negative signs. Okay, but if that happens, it's something to be aware of. Okay, final thing is the double inequality that we have to solve. So 2x plus 1, 11 and 1 on that side. And we just do exactly the same thing. Like, you can split it apart and solve them as two separate equations, like separate these into two chunks like this. Or you could say, right, my goal is x, so I need to minus 1, and I'm going to minus 1 from this, and I'm going to minus 1 from this to keep everything balanced. 0, 2x, 10, and then I need to divide by 2, divide by 2, divide by 2. 0 divided by 2, 0, x, 5, like that. So you can just solve your double inequality by reversing BIDMAS. You know, there's x, it's got times 2 and then plus 1. So if I reverse the process, minus 1 and then divide by 2, I do that to each of the parts of the inequality. Okay?